Alright, good day. It's Ishala Dedeji Mike. Once again, we're back on success enlightenment. Right, today on success enlightenment, we going to trigonometry. Alright, we're teaching trigonometry on success enlightenment today. Alright, we are going to start our discussion of trigonometry on what is trigonometry. Right, I would love to say this trigonometry is definitely a branch of mathematics. Alright, such as we have calculus to be a branch of mathematics, the set theory, the Cartesian coordinate. So trigonometry is a branch of mathematics, and in trigonometry, our central focus will be to what to buttress on the established relationship between the angle of a triangle and the length of the sides of a triangle. Now, a triangle looks this. A triangle looks thus. This is a triangle. This is a triangle, right? It has the three sides. That's a triangle. Now, it has been shown that there's a relationship between between the angles of this triangle and the sides. That is, these are the sides. These are the angles. These are the angles. This is angle 1. This is angle 2. This angle 3. Let me call that angle 1, 2, 3. And these are the sides. Let me say this size 1, this size 2, and this size what? 3. Now, trigonometry is a branch of mathematics that established that there is relationship between these angles, the three angles of a triangle, and and the length of the sides of this triangle. That's trigonometry, and that's what we'll be doing in trigonometry. Okay, that understood. Now, how do we now establish and exploit the relationship between the angle of a triangle and the size of and the length of the sides of the triangle? And that's what brought about what we call trigonometric ratio. All right, trigonometric ratio. Don't forget, I said trigonometry is a branch of mathematics that focus on the relationship between the sides, the length of the sides of a triangle, and the angles. We already established there's a relationship between each of these angles of the triangle, each of these and and the length of the sides. Now, trigonometric ratio, trigonometric ratio shows the ratios. It quantify the relationship between the angles and and the length of the sides. Right? It is not just important to know that the angles of a triangle is related to the length of its sides. Okay, that is a qualitative information. You cannot assign numbers to that. You cannot assign numerals to that. So what trigonometric ratio does is it quantify the qualitative relationship established in trigonometry. That is, if there's a relationship between angle 1 and length of sides 1, of what magnitude is this relationship? Alright? If there's a relationship between bread and butter, okay, the relationship between bread and butter, then what is the magnitude of relationship between bread and butter? Is it 2:1? That is, if you're taking 2 loaves of bread, do you need 1 butter to take it? If you're taking 5 loaves of bread, do you need 10 butter to take it? That is, what is the magnitude of the relationship? Many of you out there, you eat bread and egg. All right, fine, let me use that as a case study. Now, if you are taking a loaf of bread, now what ratio? Like, do you need 1:2? That is, for a loaf of bread, use 2 eggs. 2 eggs to take a loaf of bread. Do you take 10:5, which is same thing as 2:1? That is, for 2 loaves of bread, you take 1 egg with it. So there's a relationship between the bread you are taking and the egg you are eating. So of what magnitude it is, that's what this ratio does, trigonometric ratio. And from here, we'll be focusing mainly on this trigonometric ratio, but we must have it at the back of our mind that as far as trigonometry is concerned, what we are establishing, what we are dealing with is the relationship between the angles of the triangle, be it equilateral triangle, be it right angle triangle, be it isosceles triangle. All right, whatever the type of the triangle is. All right, what we are focusing on is the relationship between the angles of this triangle and the length of the sides of this triangle. And trigonometric ratio quantify, it shows numerically the relationship between the angles of the triangle and the length of the sides of this triangle. Now, what are the uses, what are the application, of what importance is the study of what? Trigonometry. Why must we understand trigonometry? Why do we have to what? Quantify or find the magnitude of the relationship between the angles of the triangle and the length of the sides of triangle. Before I go to the uses and importance of trigonometry, before I talk about why is it so important for us to understand what trigonometry is, before I get there, let me give you something important. Let me tell you how you identify a what? A triangle. How do you label a what? A triangle. All right? How do you label a what? A triangle. Okay? I will take this now and I will draw a very big triangle here on the board. Right? Let's have this. All right, we have this. All right, let's label this triangle A, B, C. It doesn't matter how you label it. You can start from here. You can start from here, or you can start from here. But naturally, I love to start from the top. Okay, A, B, C. All right. Don't forget, angles are actually measured in what? In degrees. Why the size could be in meter, centimeter, whatever it is, just take it. This is what ruler can measure. So this case on a ruler could be millimeters. All right. So that's for the size. All right. But for the sake of simplicity, I'm using what? Majorly centimeter and what? And meter. Okay. Now, two important features are of essence in labeling what? A triangle. Number one thing you need to know is that what? Angles of a triangle are usually denoted by what? Capital letter. Right? So that's the same way you see me putting all the apex as what? A, capital letter A, capital letter B, capital letter C. So the angle here is what? Capital letter what? B. Don't forget it's in degree. Capital letter C in degree. And this is what? Capital letter A in degree. You can't label a triangle A, B, C and you put what? Capital letter B here. Right? And you put what? Capital. No. This is A, so the angle inside is what? Is capital letter A in the, not small letter, never small letter. All right. Many times we lose our marks in examination situations. All right, based on just simple facts. All right, we just feel like it's just so insignificant. All right, and those insignificant is the reason why we read so well and our results come out very disappointing. All right, mathematics is a procedural science. It's a science of principle. Once you miss a principle, trust me or not, you've already missed it half. Okay? And those who will grade you, mark you, either whatever exam you are doing, we actually what? Marks the steps. Okay? Marks the steps. Right? They are interested in this. Alright. Now we deal with what? With the angle, the degree. Now, what about the sides? How do you label the sides of a right of a what? Of a triangle. Now, each side of a triangle, each angle of a triangle has a direct relationship with what? With the length of the side. But that is, if this is angle A, then the length of the side opposite angle will be what? Will be side A, small letter A. Small letter A. This will be small letter A. Are you with me? This is what? Small letter A. Now, the size opposite capital letter B, that is B degree, will be what? Small letter what? B. Are you with me? And the side opposite what? The C degree will be small letter C. Do you get it? This is how what? A triangle is labeled. This is how you structure a triangle. This is how you what? You draw a triangle. Don't forget the size we what? The angles will be in what? In degree and in capital letter. Why the side? Any length of the side that is facing that angle, we have what? Will be in what? Lowercase letter. Will be in small letter. All right? Small letter of the what? Of what that degree is or that angle is. All right. Now, when you are asked, for instance, if you are given this angle and this angle, and you are asked to find this angle, you can still have it like this, or you can denote this or no angle as what? As theta or what? Alpha. But in some cases, we use what? Theta. But irrespective of what you use, alpha or theta, all you are saying is what? Is you just denoting the unknown angle you are looking for. Right? But this is how a what? A triangle is what? Is labeled. This is how you label the word a triangle. Now, as this has already been understood, this subsequently in your sine cosine rule, you will find this very useful. Okay, since this has been very as understood, all right, I want to believe that everybody here already understand the difference between what? Isosceles, triangle, equilateral triangle, and all other type of triangle. If you don't, take your time. All right, take your time. It's a quick revision. Go back to your previous studies. Go back to your previous studies. All right, just quick revision. Equilateral triangle is a triangle that have all sides equal, and isosceles triangle have only two sides what equal. We also have a what right angle triangle that one of the sides must be what 90 degree. So we have acute angle less than 90. We have obtuse angle. Right, we have a reflex angle. So take your time and just brush through this at your what at your lecture time. A very solid foundation is always very important for your studies. But for this sake of this video, I'll be very straight to the point, and I'll be very direct. I will give you everything you need, right? But it doesn't mean I'm giving you everything you can know. Do you get what I'm saying by that? So fine. So now that we understand this, we can go right into what why of what importance is the study of what trigonometry, particularly to an economist. But we won't just generalize with an economist. We go beyond an economist. We will just state some functions, some importance of what trigonometry. Let's get right into it. Yeah, the study of trigonometry is of huge relevance, is of huge importance, and is of huge applications. All right, as a student of economics, all right, let's start from the economics. What are the uses of what trigonometry? Why is it important that what our students have to understand trigonometry in what in economics? All right, I'll get back to other field, but now let's focus on what economics. All right, we are going to keep it very simple. To an economist, of what importance is what is trigonometry. All right, I listed 4 importance here. All right, for economists, all right, don't forget an economist. Majorly, there are things that are very important to us. All right, one of it is what is marginalizing decision. That is, we make decisions on the margin. What is margin? Most of you have been hearing what marginal revenue, marginal product, marginal cost. All right, that is change in one variable. All right, change in another word variable. All right, decrease or increase in one variable, decrease or increase in another word variable. That is, we are talking about what the slope or the gradients here. All right, the slope or the gradient here. All right, mostly if you draw if you have this this is a graph, right, and this is a graph like this is a graph. We have this like this. Okay, economics, we talk about slope. This is what we are talking about. This slope, mostly if you look at what you are drawing a what a right angle triangle. Is that not it? Doing a right angle triangle. You're very popular even this demand curve. Okay, then this slope what demand curve. This is the slope. This is the same thing as what the margin. Okay, the same thing when you draw your total cost function, when you draw your supply curve function. When you draw anything you draw in economics, there also be a slope. All right, the knowledge of sine, tangent, and cosine relationship in a right angle triangle. When you look at this, we have a right angle triangle. You're having a what? A right angle triangle. So, and this right angle triangle properties and understanding are treated in what? In trigonometry. And you need this understanding for you to understand what the marginal analysis. All right, the marginal analysis, the gradient analysis. And that's why in calculus we have what trigonometric what derivative of what trigonometric what function. Okay, are you getting that? Derivative of trigonometric what function. So basically, but the knowledge of sine, tangent, and cosine knowledge is used in practical what economic what problem. You use them in practical economic problem. You want to find, for instance, that how does the external debt rates, external debt or domestic debt, how does it affect what economic growth in Nigeria? For instance, you want to look for how the unemployment rate in Nigeria, how it has affected the what economic growth in Nigeria. Now you have to actually have a graph like this. Let's say you have economic growth here, and you have what GDP. Let's put the GDP as economic. Then you have what unemployment here. All right, let's say you find that what the unemployment and GDP, they are negatively related. That is, the higher the unemployment in a country, the lower the GDP in the country. All right, the higher the unemployment in a country, that is, less people are being employed, definitely the lower the GDP in the country. So when you have something like this is a practical economic problem, but you have to find the magnitude. All right, the magnitude of this, that is the slope of the relationship between this unemployment and GDP. When you get to econometric studies, right? When you get econometric study, when you begin to know how to estimate the parameter of your slope in a particular function. So you are going to get the proper, more clear understanding of this. I mean you are going to know how important this is. Okay, so now how do you get this slope? You need knowledge of what? Sine, tangent, and cosine applications. All right, that's what this is talking about. So knowledge of trigonometry is very, very important in economics, because the principle, the explanation of the relationship between sine, tangent, and cosine relations in a right angle triangle is very, very useful in what? In solving real world economic what? Problem. Also, the identification of the trigonometric ratio or special angles makes econometrics analysis easier. Now, you don't have to be looking for what is sine 30. We talk of special angle. We're talking about what? Sine 30, sine 60, sine 45. That's what we are talking about when we talk about special angles, right? Sine 60, sine 90. Yes, you can have sine 90 to special angles. You don't have to be looking for where is this, where is this. We have a very, very trigonometry has established shortcut to that, right? Shortcut like sine 30, cos 30, tan 30, even cosine 30, secant 30, cotangent 30. Right? So you don't have to be pressing your calculator, racking your brain. You just basic understanding of trigonometry. Anywhere you stand in the world, anytime you need it, you can always provide that. And that has make what? Economic what? Real practical problem solving faster and what? Easier and more convenient. So the derivation of trigonometric ratio or special angle is of use in what? In econometrics what? Analysis. All right. Also, solving problem related to similar triangles. All right. One basic understanding in trigonometry, one basic discussion in trigonometry is what? Is discussion of what? How you can solve problem related to what? Similar angles. All right. Similar angles. Don't forget we talk about special angles. Now talk about similar angles. All right, this is very, very important in what? In economy, in economics what? Application. Majorly in our analysis, when you get to advanced class in trigonometry, they will start teaching you something related to what? Econometrics what? Error, autocorrelation, scarcity, multicollinearity, error in variable, there and there and there. Now you will get to realize that there's similarities in your what? In your model what? Or wrong model specification. So now the knowledge of what these similar triangles provide a useful tools, useful tools in what? In the basic understanding we need to actually analyze what? Some major what? Econometrics what? Phenomena. So the knowledge related to what? Similar triangle is of great use what? In economics. Although of the most important is this what? Understanding of the sine, tangent, and cosine relationship in what? In a right angle triangle. Economics make strong use of what? Of this application. Make strong application of this. And lastly, a bit of the knowledge of what? Trigonometric identity. Now don't forget, unlike in the physics class, all right, where majorly they are always interested in what? In drawing triangle. Now in economics, we mostly work with what we call what? Model. That's what we do in economics. We work mostly with what? Models. And models are basically in economics, they are functions. Models basically in economics, they are functions. In your basic what? Mathematics for economics 100 level, I guess, they must have taught you what is a what? A function, right? And they must have discussed what types of what? Function to you. But when you have model in economics, all right, it is more than that. But basically, model in economics, we are talking about what? Functions. And what do we mean by what? Functions, okay? What do you mean by what? Functions. Take for instance, let me use your demand theory. We said what? QD. Let's say QD stands for demand. Is a what? Is a function of what? Price. This is a model, right? This is a model. This is about quantity demand depends on what? On the price. Here the quantity demand is what? Is the what? Dependent variable, where the price is the what? Independent what? Variable. Okay. This is a model, all right? And this model, which is in form of what? Functions, can now be transferred to what? To a what? To a mathematical equations. Okay, to a mathematical equation, such as you can have for what? QD equals to what? 3 minus what? 2p. Now where do these our minus come in? Is from what? Is from relationship between what? Quantity demand and price. We know that quantity demand and price are negatively related. When the price is increasing, the quantity demand what? Is dropping. That's why I put what? A negative sign here. This is now a mathematical equation. Now what am I saying here is that what? This knowledge of trigonometric analysis is very, very useful in what? In econometrics analysis, because majorly most econometrics what? Most economic analysis, they are in form of what? Algebraic analysis. All right, they are form of what? Algebraic analysis. And this trigonometry identity, they are majorly what? Algebraic in nature. They are algebraic and they provide useful shortcut and a faster route what? To economics what? Analysis. Right. So I believe this is clearly understood. Economics use the knowledge of what? Trigonometry. Trigonometry is not only useful in what? In the science or mathematics or whatever. Economics uses this knowledge of what? Trigonometry. Of most important is the relationship between what? Sine, tangent, and cosine. Right? Those are very, very important to what? To economics. Right? Those relationship help us in what? In our what? Gradient or slope what? Calculations. All right. Also, the knowledge of what? Special angles, sine 30, the shortcut we have assist us in what? In making our analysis very, very fast. Also, the knowledge of what? Similar triangles is useful in what? In econometrics, in economics what? And not only econometrics, right? Econometrics is a discipline in economics. Let me put it that way. Okay, so it's very, very important. And finally, so I talk about special similar triangles. There's special angles. I guess okay. The main knowledge of what? Trigonometry is what? Identity. Since most economics analysis are in form of what? Algebraic analysis. Alright. Trigonometric identity provide a useful tools in what? In economics what? Analysis. This is how important is economics is what for an economist. You can take your time, go to the internet, just type or search trigonometry's application in what? In economics. You will see a long list. That's how important what trigonometry is what? In economics. Now, this is not to say that trigonometry is solely useful in what? In economics. So I will take my time. I will just itemize other uses in what? Other uses of trigonometry. Trigonometry is very, very important in oceanography. Trigonometries provide useful tools through which you calculate the what? The tides, the height of what? Of an ocean. And this is very, very important for those people that are what? That are doing seal importation, seal exportation. This is very, very trigonometry is very, very useful. Though I may not talk much on them, but I'll just itemize the usefulness of what? Trigonometry in this relevant what? Field of what? Studies. Alright, in oceanography, the knowledge of trigonometry is very, very important. Alright. In navigation, we use trigonometry. Also architecture, we use what? Trigonometry. In oceanography, it provides a means of calculating the height of the ocean tide. Many of you who maybe have been privileged to enter ship before, right? Okay, fine. Let me use the Titanic. I think all of you, let's say all. Okay, let me put it like 80%. Let's say a larger percentage of people out there, you watching me right there, you watch the movie called the Titanic. The ocean. You see, sometimes the ocean it went really high. All right. Vikings. All right. Vikings. Yes, because that was more of them traveling on the sea all the time. Right. The oceans grow. The tides went all high many times. Right. The knowledge of trigonometry provide the means by which you calculate the height of the ocean tide. It is very, very useful in navigating the sea and the ship. Okay, for the captain driving, it's very, very useful for them. All right, same thing here. Navigation used to finding out the distance of a shore from a point in the sea. All right, at the distance of a shore. All right, so definitely trigonometries provide the basic knowledge in finding distance of a shore from a point in the world in the sea. And architecture use it in in structural load. Right. Majorly when you want to have a two-story building, three-story buildings, right? The knowledge of trigonometry is important in structuring the very ground floor such that it can carry such heavy load of additional 2 buildings on top. All right. The knowledge of trigonometry is very, very used in in determining the pillar that we use for such a building. Also in roof slopes, many of you want when the rain is falling, you want the rain to slope in a particular direction. I mean the rain that is falling on your houses, you want it to flow in a particular direction. Knowledge of trigonometry is used in this. Many times where you see most of the house pan is drawn to form a triangle, right? Some forming a right angle triangle, right? Knowledge of trigonometry is the basic foundation to which this is done. Ground surface, sun shading, and etc. All right. Most of the parking lots you've seen, all right, you see, you have to just stay somewhere, and the sun is hitting everywhere. But where you are still covered. All right. Some are made unintelligently that even the sun will still be entering. That's because they don't actually factor in some things that trigonometrists have actually taught. All right, with the knowledge of trigonometries, you can actually make a shade that will actually what protect a particular space from what from the sun ray. All right, that's how important what trigonometry is. All right, this is not to say that trigonometry is only useful in oceanography, navigation, architecture. I would say practically its usefulness covers as many disciplines out there. Right, right. This is not to say that it has a universal application too. All right, but just that trigonometry is of very important, very useful importance and application in what in real world problem solving situations. All right, I will list some other usefulness of trigonometries, and by that we call this video to an end. And in the next video we focus on what on trigonometric, that is the trigonometric what ratios and what identities. Okay, so let me just list those points and we call this video to an end. All right, we're talking about the importance of or relevance or uses of what trigonometries. I say here that it is used to find the height or towers of mountains and towers and mountains. All right, anything that's have height, right? There's no way you want to calculate that height without what knowledge of what trigonometry. So trigonometry provide useful information. You can be estimating what the height of a mountain. This is a mountain. This is a mountain. This is a mountain. This is a tower of a building. So if you want to calculate that height, there is no way. You have to apply knowledge of what trigonometry. You'll be like, but you did an angle. Trust me, the house is drawn to an angle, right? If you keep to observe everything around you, it's actually built into what in form of an angle, right? It's as simple as that. Even the gadget I'm using at the moment as I'm teaching you, I can see it's in a what it's drawn to an what to an angle. Even at the standing, as I'm standing now, so you can estimate what the angle of my standing. This, I believe, this should be a what? Should be a right angle triangle. If this is a straight line, this is 90 degree. All right. Do you get what I'm saying, bro? I believe this angle 45 degree, and I believe this angle this is 90. Okay. So you use trigonometry in estimating what the height of what of a tower or mountain. All right, of importance. All right, this is very important. All right, the when the airplane is trying to take off, right? You see it moves. It's trying to take off from here. It keeps moving. It moves. Every time it moves, it's moving before it finally take off. Right now, there is a distance the airplane will take before it takes off. So with knowledge of trigonometry, that's how we get to estimate the distance the airplane needs to cover before it takes off. And this knowledge is very useful in building all these our airplanes, our airports, right? Building all our airports. This is always taken into consideration. I see some aircraft, some airplane. They tell you that this airplane cannot just start here because before it has to grow up. Because you watch movie a lot, so definitely you understand exactly what this is. So with this, we come to the end of this video, and the next video, which is very important and exciting one, success will be covering trigonometry's ratio. We start with the basic ratios. I move to the special ratios. There are certain definitions of trigonometric ratios. I will cover that. Then we move to special trigonometry's identity. It's very sweet. It's very sweet. This is just an introduction, but don't forget, all you are concerned with in trigonometry is simply the relationship between the angles of the triangles and the length of the sides of that triangle. And we'll be using mostly the right angle triangle in trigonometry. Right, it's most important a special case of triangle we use in trigonometry's analysis. With this, I come to the end of this video. I remain my humble self, Ishola Adedeji Michael. Don't just watch the video, like, subscribe to the channel, feel free to comment. If you have any problem understanding, maybe I'm too fast, maybe you want me to explain to you personally, or fine, I can do that via WhatsApp. Message me, chat me up. I can give you a voice note that explains the part you don't understand. And if you have any problem you're trying to deal with related to this, you are preparing for a particular examination, and you are facing a particular problem on it, feel free to share this with me. Call me anytime. I'll pick your call, and we can have a one-on-one conversation. All right. Till next time we meet, I am my humble self, Ishola Adedeji Michael, and thank you for watching.